jarhead fire and tree mortality, and how the FWC responded to that. Currently, I just confirmed cluster 101 earlier this week, so we have 92 active clusters in Big Cypress. 90 of those are potential breeding groups. You can look and see the off-road trails here. Oasis is down here, Monroe Station, Windmill Tram, and airplane carriers up here. So we have a pretty big congregation of birds north of Monroe Station all the way to Oasis and all the way into Raccoon Point. We have 2 single females down in Lawson's Pines, and they should show up down here. There's still a small relative population down there, 3 potential breeding groups with 2 single females. We've installed some recruitment clusters here, here, and here. 2 of those are active, 1's inactive. All these blue crosses are historically dead clusters where there's no trees left. And this is so. I kind of put all this together over the last 4 years. In 2008, we only monitored 30 clusters, and since then we've monitored a minimum of 40 clusters. Due to early nesting and early fledging, we can add some more in at the end of the year. And so I can figure out now, with this amount of data, I can figure out the first nest success rate, second nest, and third re-nest if it's if the conditions are right. So by far the most successful time for an RCW to be hatched is going to be the first nest. 2010 and 2011 have almost identical success rates, but we had lower production in 2011 either due to the drought or the fire. We only abandoned 21 nestlings this season. 18 of those fledged, but we also confirmed anywhere between 14 and 15 more fledglings that we didn't get to ban because of access issues with the fire. So for the first 2 years, we didn't see any third nest attempts. Last 2 years we have, and that's little birds put a lot of energy out. Because their third attempt at nesting and actually having it succeed is really something else. And so totally, we banned 125 nestlings in the last 4 years. And here's the kind of graphical look at what we're doing. Yellow bars are nestlings banded. The green bars are the number of those nestlings that actually fledged, hopped out of the cavity, flew around. Red bar is the number of unbanded adults that we captured in the off-breeding season. And the blue bars are the number of RCWs that we've actually recaptured from prior banding events that the Park Service was doing since 1991. Had a great year last year. The average group size is above the bars. We take an average population census and divide by the clusters that we monitor. 2010, we had a lot of helpers with the groups. And this year, based on the numbers of birds that we banded, the average group size dropped down to 2.8. But since we include the total number of nestlings that we documented fledged but didn't ban, that's going to bring our group size up to around 2.9. And that yellow bar would actually be, yellow and green bar would actually be quite a bit higher. So hopefully y'all know that we did have a fire out here. All the jarhead burned 32 clusters. 30 of those had pairs. Red is active, blue is inactive. The light blue is the perimeter of the jarhead event. Lost some trees. Counted as of last week, we're up to 20 lost cavity trees that were active or suitable for RCW use. We didn't actually go out and look at the unsuitable and dead trees yet. Just didn't have enough time, so this winter we'll start doing that. And based on those findings, it's going to be really interesting to see the cavity competition between red-bellied woodpeckers, RCWs, bluebirds, flycatchers, and anything that nests in the cavity. We have not documented any flying squirrels yet, so that's good. So there's been concerns about natural mortality from fire. 2008, data was given to the FWC. We went back and started checking out those trees. And this is just the transition between each year from trees that were designated alive to dead the next year, naturally. These are these are all natural cavities, these aren't inserts or anything. So from the data we got in 2008, and then when we checked them in the summer of 2008, there's 13 trees. Trees that were documented live in 2008, and then dead in 2009 and 14, and such and so forth, 2009 and 10, there's 15, and then the natural trees lost from 2010 to 11, there's 15. Naturally, then there's about 20 more that I added in from the jar event that is only going to increase. And so this is all, I didn't have time to go through and pick out, or, I got hit by lightning and got blown over by a tornado or a storm or whatever. But these are just natural deaths for some reason. So we did go ahead and put in artificial cavities after the jar event. Why did we put artificial cavities in? Well, the wind-thrown trees, this is an old willow tree that I found in 2009. It hadn't been burned up yet. Natural loss is a short little cavity. It's been just beat the heck, fires and just being out in conditions. And then fires, this is one of the hardest hit areas behind the blockhouse, if anybody's familiar with that area. Some arsenic bad there. So we'll go in and put in artificial cavities to augment these populations for the Fish and Wildlife Guidelines for suitable cavities per active cluster. So this is a total of all the artificial cavities we have put in Big Cypress from late 2007 to this summer. We put in 107 cavities. 99 of those trees are still alive, only 8 are dead. So that's pretty good percent. 7% are dead. People hope for 20%. They think that's good. We're way below that. Out of those 107, 89 are still suitable, and artificial cavities can account for at least 18 successful RCW nests in the preserve. Once again, this is data from late 2007 all the way up till this jar event. Of the 8 cavities, 4 were killed from lightning, and then 4 just couldn't take the insert. They were stressed out, maybe 4 or something. And all of those inserts that died were installed in 2007 and 2008. Anything from 2010 and 11 has not been documented yet. Of those 18 that I mentioned that are unsuitable, most of them are unsuitable because they're dead. A lot of them, and fire damage, some of the short ones. We do have some water issues. And I've looked, and I used to think there might be a correlation between unsuitable cavities and height orientation, but there really isn't. Short trees are more susceptible to fire, just like any natural cavity. Sap is flammable, and it's just more susceptible to fire events. Water and screen things we can fix. Some of the old inserts that were installed didn't have drain holes at the bottom, so they're going to hold water if there isn't a way for it to get out. And anything that's screened has some sap leakage, and we can still fix that with some simple wood putty. This is just kind of a basic rundown of the types of cavity trees out here. Tallest cavity tree out here in Big Cypress is 72 feet high. It's a giant. Shortest one's about nose height. Average orientation is 207 on a compass, so south-southwest. Got a big 55 centimeter DBH tree out in the middle of the prairie. And so when we put in these artificial cavities, we only do it 10 or 20 feet high. It's really tough to find an artificial cavity tree with the right diameter after 20 feet. So this is just kind of run down how these different techniques compare to natural cavities. And you can see our orientation doesn't differ much. The drill cavities got a little turnaround. But every time we put in these artificial cavities, it goes on the underside of the tree. So that way sideways rain doesn't come in, and those birds can actually get into the cavities. Then I broke it down again on how we approached installing these artificial cavities and how they responded. So artificial cavities that we put in the active clusters with birds present, but they seem to work the best. 68% of the 68% of them are active right now. That's amazing. 4 of those are dead. Artificial cavities put in recruitment clusters constitutes where we think there's a good area, such as Lawson's Pines. We'll put in a recruitment cluster in an area that there was no historical cluster there. 51% of those are active right now, and the star is there, the asterisk is there to mention that 2 of these recruitment clusters are in Lost Wings Pines, and there's only a limited number of birds down there. The cavity use by inactive cluster or augmentation is where there's no suitable trees left in an old cluster. The trees are still there. It's it's around active clusters. They have 67% of those inserts are active right now. Whereas natural cavities, we checked 69 of them. Some of those are from prior years. We have 746 trees now. 356 of those are suitable, and out of those, 41% are active. That active 2011 down here does not include any of these, and so it's going to be up. But this kind of shows that the birds don't depend on these artificial cavities, but if they're there, they're going to use them. A couple examples of artificial cavity use. This on the left is an insert box that was installed in 2008. Can't really tell it's there anymore with all the sap covering it. You look pretty close, there's a woodpecker in there. And this is a drill cavity down in Lost Wings Pines. It's been in the nest here the last 2 years. Biologists told me that the cavity that doesn't get installed doesn't get used. In Francis Marion National Forest, there's kind of a template for that. A lot of people don't remember. I was pretty young, but Hurricane Hugo came in and knocked out. I have the numbers here somewhere. They knocked out almost 63% of their birds. They just killed them in one night, and then the hurricane knocked over 87% of their active RCW trees. The next year, they installed 940 cavities. They had a 40% increase in the population. And since then, they've fledged over 3,000 nestlings in Francis Marion. So that's a true increase in population by using these birds in a catastrophic situation like that. The best part of this is less than 1 hour of installation constitutes many years of use for an endangered species, and there's not a lot of endangered species that can give us that opportunity. We're climbing trees, we're banning nestlings, and as Pedro said, safety is number one concern, and it always is. We're never doing this by ourselves. We have radios, we have communications with the outside, and so we're specifically trained to do this. Don't try this at home. So it's pretty neat to see. This is a drill cavity I took a picture of in October. Cluster 35 at the Oasis. That's the pledge from this year living in there. This is actually a drilled start where they just took a hole and just drilled a hole in the tree. And this is an insert down here getting the bird to go into.
I'm sorry, does the bird open up the cavity after he goes in the drill hole, or do you?
They expand it once they're in it, but we put these restrictors up. A metal one here, then some crosswire to keep the red bellies and pileates from coming in and destroying it. So it can only get so big. As far as references go, I know there's over 1,300 references for RCWs. I cited the top 2 first ones constructing inserts, I believe, and then this one's the drill cavity techniques. And everything that we do is based on the U.S. Fish and Wildlife Service recovery plan. If you have any questions about that, I have a copy with me. If not, I recommend reading these publications if you're interested. And before I get done, I want to say a big thank you to everybody here. The resource staff has been really amazing for our project. The fire crews this summer getting us out to survey these trees, roads and trails folks at Big Cypress here to help us if we ever have mechanical problems, and aviation, getting us off the ground in the Lost Wings. I'd also like to thank the folks at Picayune for letting us come out and take a look around, see what they kind of have for RCW habitat. In fact, the hatching staff got to go out a couple times and take a look and see what they have for RCW habitat, and then same with the Color Seminole staff. I really appreciate you guys letting us come out and just taking a look, because someday this population is getting so big, people are going to start seeing birds somewhere. And it'll take reports of sightings, whatever you got, and so it's just the population's getting bigger, and the habitat in the surrounding areas is getting better. So, in closing, I just want to say a big thank you to everybody.
The effects of roads on wildlife has been the topic of many studies, many publications, and many conferences throughout the world. In 2009, I was asked to write a case study on the effect of the underpasses built on I-75 for the Florida Panther. So I co-authored a chapter in the book with Krista Sherwood, who is the transportation scholar here at Big Cypress, and Elizabeth Fleming, who works for Defenders of Wildlife, which is a non-government organization very, very much involved with wildlife and transportation issues. And the outcome was a chapter called The I-75 Project, Lessons from the Florida Panther, and published by Island Press last year in a book called Safe Passages, Highways, Wildlife, and Habitat Connectivity. So what I'm going to be doing is speaking on what we did for that, to write that chapter, and some of the field work, and what our recommendations are. We went through the historical documents and the publications on the results of the study. We looked at the databases on panther mortality and crossings, both from the National Park Service and from the Florida Fish and Wildlife Conservation Commission. And we also did some field checks. We did a wet season and dry season field check, actually, of the underpasses. And one reason we did that was because in looking at the literature, there was not only discrepancy of what the dimensions of the underpasses were, but also how many underpasses were actually up there. So we went up there to really just measure those dimensions, and in doing so, we found that there were other things that we needed to be examining. A little bit of background. Highway 41 was built in 1928 across South Florida, and then in 1967, Alligator Alley was built. And it was only a year later that an interstate was proposed to cut across South Florida. And this was because of knowing that there was going to be so much more human development on both coasts. They were already seeing some negative effects of the alley on the hydrologic flow. But at that time, there was no mention of panthers because a lot of people thought that the panther was extinct. And then in 1973, the Big Cypress Area of Critical State Concern Act was established, and this was, again, looking at the hydrologic health of the entire state of Florida. And they were also concerned about conserving Big Cypress Swamp at that time. They were concerned about the water flow to Everglades, as well as the fisheries and the aquifer. So because of that, there were some large areas of land put into public ownership, such as the Fakahatchee and Big Cypress. And during that time, the alley went through, and there were a few panthers that were being killed on the road. So there were a few left. So the state agency started an intensive program with telemetry, and soon realized that there really were only a few panthers that remained. So they also looked at this then as an opportunity in building I-75 and planning it, designing it, to do it with wildlife in mind. And in 1982, the Florida Game and Fish Commission sent a letter to the governor saying, because of the very small number of Florida panthers believed to be remaining, the loss of a single animal should be considered significant, and any redesign of roads in known panther habitat should fully accommodate this concern. So construction began in 1986. It was completed in 1993. The cost was about $99 million for construction and another $155 million to acquire the land and for severance of access rights. So here's the project area. It's about 40 miles from the western side of what is now the Panther Refuge all the way over to the Broward County line. And we found that there were 35 underpasses. Some evaluations of the project included one by Foster and Humphrey, in which this was during construction, and they used radio-collared bobcats as surrogates for what panthers may do. They saw that female bobcats rarely crossed, they saw there was human trespass, and they recommended that the fencing be routinely inspected and repaired. And Lotz, Land, and Johnson from Game and Fish prepared a report where they examined 2 existing underpasses on I-75 and two that were built on Highway 29. They found there was more panther use on I-75, which would be expected because animals would get used to it. But they also found that there was standing water in those underpasses for 4 months of the year, and they felt that it may have an impact on wildlife and recommended grade adjustment. So those were the only 2 studies on I-75. So just briefly, from an aerial view of the road, I'm sure you've all driven the road, but the fencing is about 240 feet from here to here. The fencing is a typical 10-foot high chain link fencing with the barbed wire outrigger, and it's continuous from one end to the other end, the 40 miles, except for State Road 29 and Turner River Road where they cross. And what we found of the 35 underpasses, that 23 were what we called wildlife only. They were for accommodating wildlife, and they averaged about 75 feet in width. The clearance underneath the road was about 7.5 feet. And these were put in known corridors where radio-collared bears and panthers they knew had used those areas. And of course, we're looking at habitat corridors, knowing that that's what animals use. Then there were 12 water and wildlife crossings, and these were about 130 feet across, including about a 30-foot pathway for wildlife crossing. So here the concept, we're looking north to south, is a crossing or a berm going over the canal, going under the road, and then a crossing here. And some of this, these were discontinuous canals at some of them, so that they would fill up, and then when the water levels were high, they would sheet flow further into the south. And these had about a 5-foot clearance underneath the roads. The average distance between the underpasses was 1 mile, and it ranged from 1/4 mile to 3 miles. So again, these were some other things that we looked at because we saw these things when we were up there. We found fence openings, and on the main road, of course, they're caused by car accidents, but underneath the fencing, they're caused by illegal trespass. Probably someone wants to get in there to hunt or to go fishing in the canal. And these are not inspected routinely, but if they're reported, then the contractor will come in and make the repairs. So remember, we looked twice. We looked in October and April, and we found in October that at 27 underpasses, there were 38 cuts in the fences. So we notified the contractor, and we went back in April, and 29 of the 38 had been repaired, and of course the other 9 may have been repaired and reopened, but we found an additional 21 openings. On the main road, as you probably know, what's been installed was an alarm system, and it's essentially that cable that runs along the road, so that if it is breached, then the authorities are notified. We found non-native plants in most of the underpasses. Big Cypress has spent $12.5 million to date to treat invasives. So having these seed sources in the underpasses is really not a desirable situation. We also found water, an average of 6 inches of water in the wildlife-only underpasses, and 20 of those, and up to 14 inches, and then in April, which would be expected, they were dry. Now, it's not known if water impacts wildlife crossing. Of course, they live in water here, so we don't know if that water in the underpass had an effect. We did find, this is a crossing of the canal on the north side, and we did find, this is actually a crossing here, and it was breached just from the natural flow of high water, that this was actually a waterfall that caused foam going down there. So essentially, this crossing is non-functional for wildlife. Of course, we found some panther tracks under there, a lot of other wildlife use, and a lot of human tracks. But at 7 underpasses in October that didn't have standing water, so we were able to look at tracks. We found panthers at 4 of them. And then in April, at 15 of the underpasses we could access, we found panther tracks at 12. Of course, we do acknowledge that without, impact from the weather, once those footprints get embedded in that soil, they're going to stay there for months. We also found bear and deer tracks outside the fencing in situations like this, where there was a big breach in the fence, then wildlife could easily access, and the highway patrol do get calls about deer up on the road. For the past 30 years, 158 panthers have been killed on Florida roads, and this accounts for almost 50% of all their mortality. When it was Alligator Alley, there were 5 panthers that were reported and found, and since the project, the I-75 project, has been completed in that area, 2 panthers have been killed. 1 possibly got through a hole that was cut in the fence, and another one is on the entrance ramp at the State Road 29 interchange. Also, since 2004, this is about an 8 to 9 mile segment between the Naples toll booth and where the fencing starts. There have been 9 panthers killed in this area. And then on the other side, in 2009, there was 1 panther killed just outside of the. So the big question is, are panthers using the underpasses? Yes, they are. We looked at 163 panther home ranges of panthers whose home ranges were within a mile of I-75, either on the north or south side. And we found that 91 of the 163 samples we looked at did overlap that buffer area, 61 males and 30 females. Again, this is showing you the same thing what we did. We looked at their home ranges, and if they were close to the project area, within a mile of the road, then we counted them in our sample. I want to thank John Kellum and Steve Schultz for helping with the analysis of this project and doing the graphics. We used the animal movements software, and we determined that just over half the males within that project area crossed. And 4 of them crossed. They were dispersers. They never came back to the area. Of the other 28, they averaged 55 crossings. 1 crossed only 2 times, 1 crossed 242 times. So half the males were crossing underneath I-75. Of the females, only 17% of the 30 that we looked at crossed, and they only crossed 1 to 3 times. So why was there a reluctance to cross? The traffic volume on that road in 2007, the daily traffic, average daily traffic volume was estimated at 18,700, and there's studies that show effects on carnivores of crossing at 1/3 of that. Maybe it's the crossing distance, maybe it's that water inundation, maybe it's human activity, although I would think that occurs during the day versus animal crossing at night. Maybe there's too much exposure between the 2 roads, or maybe there's some lack of, some difficulty of travel or lack of clear view, and I'm going to show you that. I would think that wildlife would want to have some kind of line of sight of where they're going, and we found a lot of vegetative growth in those underpasses. Yes, they need cover, but is too much cover and not a pathway detrimental to them? This is one of the pathways underneath one of the water crossings, and this is all cattail. And, is this hindering animals, and maybe especially like deer, from actually using the underpass? This is another example where evidently work crews pulled the vegetation off the fences, but this is very, very rank for most animals to really feel comfortable using them. So we concluded that yes, the project reduced roadkills, it maintained habitat connectivity, It enabled genetic interchange of the species, and it allowed for dispersal. However, the road is a filter barrier because it blocks some, but not all movements, but especially the movements of the female panthers. So Florida was recognized as an innovator for large-scale wildlife crossing implementation and transportation planning. But the question is this I-75 project work over? It's a standard in studies now on crossings that there be post-construction evaluation and that there be long-term monitoring. So our recommendations are that there be routine inspection and repair of the fencing, that the exotics be removed, that those reef crossings be repaired, and that there be a more rigorous evaluation of what we attempted to do in looking at the wildlife use, especially in relation to the vegetation, the density on those pathways, and the water levels in the underpass. And then we also recommend to extend that fencing along that 8-mile section where panthers continue to be killed. Thank you.
Well, prior to changing gears, for years we've been working on the panther refuge to cut cabbage palm, actually to look at cabbage palm and its effect on the ecosystem. And what has happened over the years with our reduced hydrology is that we found cabbage palm just to be taking over much of the panther refuge up in our uplands and even in our prairies or pine flatwoods. So we did quite a bit of research, some of it involving our fire program and other programs, and kind of concluded that, in fact, it's the hydro period that's been altered through the canals primarily that have allowed our cabbage palm seedlings to survive during our, what would typically be our wet season. And of course, that's not happening anymore, at least for the most part. And so our objective became to restore our ecosystem, and cabbage palm cutting is just a band-aid. The real issue is actually restoring hydrology. I just said that. And so, as of about a month and a half ago, we finished cutting about 4,900 acres of cabbage palm on the refuge. I never want to see a big machine on the panther refuge again. That ever comes out when I said so. But we've been cutting cabbage palm for about 5 years, about 2,500 acres on the east side, and almost that amount on the west side. Some of it we actually cut with chainsaws, but most of the work was done with fellow bunchers, hot saws. They have all kinds of terms. A piece of junk. But anyway, in 1953, I pulled this aerial up, the black and white obviously on the left. And just wanted to give you an example of an area on the west side of the refuge where you have, back then anyway, quite an open understory. The cypress would be that gray, or really light gray heads. And then you have that prairie in the middle, and your pine, you're going to see kind of filtering out in an area like this. And you look at the same area now, it has, well, not much, but it's been taken over by cabbage palm. And it's been quite a sight, and I have to blame Mike Dugan for this graph. Everybody uses this, right? I just added pretty colors to it. But looking at the effect of canals and their resultant effect on superficial aquifer, to me, it's kind of, but over the years, the I-75 canal and the Barron River Canal have done quite a bit of damage, I would say, to the panther refuge, not to mention Big Cypress to the east of us. And that effect has allowed these few cabbage palms that we used to have, maybe 1 or 2 or 3 per acre, that we tried to still preserve. We didn't cut down on the cabbage palm. Back then, a few per acre versus now I have areas where I have 2,200 cabbage palms per acre. You cannot see the ground. And in some areas it's pretty typical. So we go in with this fellow buncher, and this one is a tiger cat. It makes just as much oil as a Timco. And then of course on the right-hand side, something where it's an area where it's just been cut. Here's a different machine Depending on your operator, this last contractor I had was really light on the land. He knew how to turn that thing without disturbing much, but there are issues with going in anywhere with bigger equipment. And we're dealing with those issues in the probably over the years. This is one of our worst units, Unit 1 on the very western side of the refuge, and that's cabbage palm laying down, and that's, they were talking about, you know, a couple thousand cabbage palms per acre, at least 100 cabbage palms that are cuttable size, 2 meters or taller per acre. So, and then this is the eastern side, which we finished cutting about 40 years ago, and this is what it looks like now. And I have issues. I have a crew in there right now spraying cover grass in this particular area because we've increased that sunlight. It's great. Was the coating grass there before we cut the cabbage palm? Probably here and there. Could we have gotten it out of there before we cut the cabbage palm and stirred the soil enough to where we just presented the seed bed for coating grass to take off? I don't know. But I've got a crew in there now. Another crew starts on Monday. Only about 2,100 acres of coating grass to be sprayed here in the next into December. So anyway, you look back, you have to put the Band-Aid on the problem by cutting cabbage palm. If you don't fix the hydrology, the cabbage palms are going to come right back. You can't cut the young cabbage palm, you have to spray that out. We've been experimenting with different kinds of herbicides to do that in an effective and safe way. But there are issues with the hydro period, and that's what I'm really trying to get back to. The changes over time have been, for me, having been here about 20 years, pretty stark. Of course, you have this increased seedling palm survival. Everybody knows the palm tree is the dead tree. If you don't know that, just ignore it. It's not a big deal. It's just a political thing. But also, over time, you have this unnatural impact of the forest structure. And if anybody visits out there, and we still have a lot of places where we haven't removed all the cabbage palm, well, actually, we've not removed all the cabbage palm anywhere. But where we do have cabbage palms, we've been working on a fire on the Panther Refuge. If you don't lose the fire, it's going to be because of palm fronds blowing across the road. So, and our fires are much, much hotter. They've gotten much hotter over the years. When we first started burning back in 1990-91, much cooler, and now it's a fireworks show. Of course, the upland plant invasion is occurring into the wetlands. Coating grass, fortunately, is stopping right at the prairies, but that could be a soil issue too. Mike Berry will probably weigh in on that.
Definitely the wet prairies are resistant. It's awesome.
Yeah, and I thank goodness that I have enough wet prairie in places to keep it out. But also, because of the reduced hydrology, I don't have those long periods of flooding, which brings me to this place today, that might actually help keep coating grass out as well. And also, increasing plant diversity, where you have this thick cover of young and old cabbage palms. The plant forage diversity is not there as it used to be. And we think it's coming back in places where we've removed, cut and sprayed the cabbage palm. And I'll talk later on this afternoon about our orchid project, but here's another fascinating fact about the lack of water is our swamps are drying up. So in the wintertime, when we get those really cold nights, we have orchids that are freezing. Our epiphytic orchids are freezing. And that's not good because they're long-lived plants that are really dependent on that thermal buffer that the water in the swamps provides during the day to absorb that solar radiation and give it off at night. A few years back, I hung a bunch of data loggers in some trees and was looking at the effect of that thermal buffer caused by water in the swamps. And in the hammock about 50 yards from a particular swamp, we had a 32-degree night. And all the data loggers from ground level all the way up to 10 meters high, they were all reading about 32. But in the swamp, my lowest data logger right next to the water was 38, and then went to 38, 36, 34, 33, and only at that 10-meter level did that data logger actually reach freezing because of that thermal insulation that the water provides keeps my orchids from freezing. Your orchids. And I know Dave Schindler's here. I don't know who else might be here from the Conservancy. The Conservancy did a survey a few years back looking at the number of alligators that are migrating into the canal, the very canal next to I-75 that Dan was talking about previously. And in a 7-kilometer stretch, they counted over 600 alligators at 2 meters or longer in my canal. I mean, Peter Pan could walk across the back of those with no sweat. So an issue is when the water dries down, the alligators migrate to the canals. And the females, if they nested, if they laid their eggs and they hatch them off, they'll actually abandon their group, their kids, and migrate eventually to those canals as well. On the east side of the refuge, routinely I follow the tracks of a female that walks the 1.5 miles from McBride's Pond out to State Road 29, goes under the overpass and jumps in the canal. And then a few months later when the rains come, she walks on back and we can follow her tracks all the way down the road. That's what she do. And of course I spoke of the exotic plant invasion. I mean, holy crap. It's hard to keep in front of this stuff. And hopefully this year we'll actually make some really good progress thanks to some of our money and also FWC's money that has allowed us to pursue that. And just a few pictures here. Just to show you, this is in Unit 6 on the west side. You can just see the influx of these new cabbage palms coming on. This is just, about 2 weeks after a fire, and it's just an invasion. Of course, really, really hot fires. On a day when the wind's not blowing very well, very hot. The tree canopy just scorches. And we've got some really good areas where those future red-cockaded woodpecker trees, they're not. So, just really hot situation. And by the way, we discovered you can't hardly kill a cabbage palm with fire and wheat dry. And fire is a very important part of our ecosystem. It's trying to balance the right temperature, the right kind of fire that we either set or to have the habitat conditions so in a wildfire situation you don't have these tremendous flames. And this is on I-75, just this side of the toll plaza. And if you look at it now, all the cabbage palms are really in good shape. And you just see this skeleton forest of dead pine trees, typical of a wildfire with a mid-story canopy of cabbage palms that get so hot that they just wipe out all the pines. This is right after a fire, and then immediately after, within days after cutting the cabbage palms. Actually, it was cutting the cabbage palm and then we burned it. And this is Kogan grass, Unit 26. Dennis has been there many times treating Kogan grass. One of the other issues, as I mentioned with the hydrology, we sunk some wells. We're looking at the impacts of these activities that we're doing, as well as just monitoring our well being through a network of 9 different wells on the refuge. Then, as of yesterday, I had a committee meeting with a graduate student, T.C. Huss with FGCU, and he and Dr. Brian Barr are looking at the transpiration rates of cabbage palm versus pines in our particular part of the ecosystem. And his thesis actually be finished sometime in the spring and graduate in the spring. And so I'm looking forward to the results of that. But coming up with numbers that probably would say that the rate of transpiration of a pine tree versus a cabbage palm are the same, or roughly, statistically the same, but for the fact that we've got 30 or 40 pine trees per acre, and again, we've got 2,000 per acre of cabbage palm. So we're wondering if we're just actually really pulling more water out of the ground. And of course, since we cut cabbage palm on the east side of the refuge, we've had an RCW both sited as well as located by sound coming into the refuge. Find them in the heat centipedes, and they love scorpions. And then we just started, Dave Schindel and I are embarking on a new annual inventory monitoring program with these remote cameras. We're going to place upwards around 70 cameras on the panther refuge that will work into an annual inventory and monitoring plan. This year we're going to run pretty much 12 months straight and start quantifying the other issues that we have, certainly panther activity, as well as all of our other animals that are subjected to being taken programs. And just to show you the three main issues I have, I-75, and the American canal system, which I'm concerned about because of the new water reservation that South Florida Water Management District has declared. So I don't know how to do something about the refuge. And I think that's kind of it. By the way, these prairies back here, they're not prairies anymore. They're caved in the cabbage farm. I think I'm done.
Thanks, Larry. We're on a break till 10:30. Thank you, Tim. What I'd like to talk about today is it's part of a larger program that the USGS has been involved in trying to quantify evapotranspiration rates here in South Florida. And some of you may be aware of Ed German's work that was done at Everglades, where we had numerous evapotranspiration stations. Barclay Shoemaker has followed that up here at Big Cypress and has 5 evapotranspiration stations currently ongoing. One good drop, but there's a report coming out early next year that will document that work. And this work is tangential to that, but I thought it would be interesting for this talk today. I want to look at the role of surface albedo in the energy budget of Big Cypress National Preserve. And the reason you might have some interest in that is the energy budget drives the water budget. Available energy drives how much water is evapotranspired. So that's where it is. My partners in this work were 2 fellows from the South Florida Water Management District. One fellow is John Klopik, now moved on to the U.S. Army Corps of Engineers to the area district. First, to define terms, I'm sure this is reviewed for most of you, but albedo, just the concept of albedo. It is really the fraction of incoming solar radiation that is reflected back to the atmosphere. So it tells you how much of the incoming energy is retained and how much goes back into the atmosphere. So it's simply that ratio. And you can look at a graph here of reflectance versus wavelength and see that that's not a simple quantity. It's, down here in the visible light range, you have very little reflectance of light by living plants. More reflectance by dead plant material. You get into the near infrared and that switches. So it's a very complex relationship between reflectance and wavelength. What albedo is usually an integrated version of all this. So we just integrate over, say, the shortwave range and give it one number to kind of simplify it and tell us something about the energy budget. And another definition of terms here, the Earth really has, for the most part, 2 dominant sources of input and output energy at a planetary level. One is shortwave, which is sun-derived. Sun's at about 6,000 degrees Kelvin and is emitting this radiation that's in this frequency range, or this wavelength range. The visible light is just a subset of that. Over here is another big relevant energy range of longer wavelengths. And this is the radiation that's termed long-wave radiation that's emitted by every piece of matter on the planet. But at a much lower temperature, at about 288 Kelvin, or plus or minus a few degrees there. So we have these two bands of radiation, short wave and long wave, and they hardly really cross. So that's just part of the vocabulary of this. And let's look down here at the bottom first. The net radiation is a term that's often used in evapotranspiration studies because that's driving the whole process, energy-wise, of evaporating water. And it's a composite of four terms. We have the incoming short wave or solar insolation. We have the reflected solar insolation, this alpha being the albedo, that's the matrix in this slide. And then we have the long wave down coming from the atmosphere to the Earth, and then long wave back up, radiating out into space. And the composite of all these terms is the so-called net radiation. And net radiation then is dispersed or used for various purposes. Some of it comes off as sensible heat, that's just convected heat. And then here's the critical thing for most of us in this room is the latent heat flux. Latent heat flux is the energy equivalent of evapotranspiration, which is mass flux. So it takes a lot of energy to have that phase change from liquid water to vapor. As you might feel when you get wet in the summer and the evaporation cools your skin quite a bit. There's a lot of energy involved there. And then there's also energy going into storage. That's kind of a transient phenomenon. Over a day or two, it doesn't really matter. And then, of course, something that's of interest to biologists is photosynthesis, the energy that's actually going into fixation of carbon. Turns out that is a very small piece of the energy budget, hardly worth mentioning, a percent or two. As important as it is to us, the big terms are sensible heat and latent heat. So we have this radiation driver, and then that gets split into either coming off as heat or evaporating water. And here's the twist that's of interest to us is the latent heat, of course, is the mass equivalent of evapotranspiration. And precip minus the evapotranspiration gives us the available water that's left over to do the work of either infiltrating into the ground or running off down the Florida Bay. And it's interesting that both the net radiation and the available water are differences. So a little bit of, anytime you take a difference of two numbers that are somewhat on par in magnitude, a little bit of error gets amplified in their difference. So that's one thing to consider. And so we see this coupling of the energy budget and the water budget through the EC, latent heat flux area. And this is important not only at our local level, but globally. The objectives of this study were to determine the temporal variations in albedo at typical forested land covers in Big Cypress National Preserve. And these sites were coupled with work being done by Barclay Shoemaker, where we're actually measuring the evapotranspiration. The land covers were identified by Mike Duber, looking at the most representative land covers in the preserve that we could cover with a few sites. And then what are the causal relationships for albedo variability? And then these are just a couple of sites that we're putting in to measure albedo. We'd like to have albedo everywhere so we can start to understand the energy budget of the whole South Florida. So we use MODIS satellites to capture that albedo variability. So we're going to check, see what MODIS says about albedo, compare that to our measurements. If it works out, then we've got albedo everywhere, every day. So what we did was we put out these four component radiometers that measure short wave, long wave, incoming, outgoing, four components. So you see two of the sensors look up. This is the short wave sensor, this is the long wave sensor looking up, so measuring incoming. And then we also measure reflected short wave and outgoing long wave radiation. And these were the three sites chosen to do this work. They're all on the towers, so pretty extensive forested area, so we have good correspondence between the local measurement of albedo and the larger scale satellite-based measurement. And We measured radiation at 54-second intervals, composited in half-hour averages, and we've done that from April 2008 to present. And I'll just show you a few pictures of some of the sites. This is the so-called Pine Station. There's actually interspersed Cypress here. This is up good ways north of 41 on 11 Mile Road. And we have, in this case, a 120-foot tower, and we installed the sensors here near the top. So you're looking out, the rule of thumb is the source area of these sensors, the radiation sensors, is about 3 times the height of the sensor. So this is about 120 feet, so you're averaging something at like a radius of 360 feet. You're getting a measurement looking down this forest we cover pine trees here. Here you can see a climber going up. This is another site on Loop Road, Dwarf Cypress Station. So you see the Dwarf Cypress trees here, much more open canopy, a little bit shorter tower, only 60 feet here, 18 meters. And this is another tower, it's a little bit harder to see, but right here, this is also on Loop Road, what we call the Tall Cypress site. So pretty extensive cypress area there. So we have 3 typical forest coverage here in the preserve. And here's the time series of those 3 covers. Remember, this is albedo on the y-axis and time on the x. And the dwarf cypress site is shown with the blue dash curve. And so, for instance, here, 0.15 was the local maximum here. That's about 15% of the energy is reflected back. That's what it's implying. Here we got up to a peak of 18%. So you see that there's a lot of variability. It's not a constant value. Oftentimes in this work, people assume a constant value of albedo. For a grass cover, it's 0.23, that's what it is. But you see there's actually a lot of variability here. Primarily in the dwarf cypress side is showing the greatest variability. The tall cypress and pine also show variability, but not quite as much. I was going to mention the very high albedos that we're seeing here at the dwarf cypress site, I think are probably related to the fact that you've got a sparse canopy and ample amount of parapite, which is pretty reflective. Looking at here a graph of the albedo, which is shown in blue for the dwarf cypress side, and the water level, which is this light gray line. We see a very clear relationship between the water level and the albedo. That actually here the well was dry and water levels were so low, and we couldn't, as you know, the limestone is pretty close to the land surface, so we couldn't penetrate too deep. We ran out of water here and here, and this is basically land surface 0. So very dry times, the albedo was very high. And you can see at this side, as the water level came up, and it was probably quite a bit deeper here, but it came up and now it's inundated in the surface, you get this dramatic decline in albedo. Same thing happened here. Once you inundate the surface, dramatic fall of albedo. So water is known to have a low albedo, surprisingly enough. It actually absorbs most of the shortwave radiation compared to vegetated surfaces. So that makes sense. But it's showing the strong control of water levels on the energy budget through the albedo. And then as you inundate the surface, this is the 0, this is our estimate of land surface. So as you inundate the surface, the albedo continues to fall. And I think that what's going on there is you're starting to submerge vegetation, so you're obscuring vegetation and making the water more the surface that the atmosphere sees. This is the pine site, and we see the same thing here. Here's the well going dry here, and we see the highest albedos. Here you have a very high water level, in other words, very wet, and the albedo is low. So we're seeing that same phenomenon. Same for the tall cypress side. Dry well here, highest albedos, high water levels, low albedos. And this is just a graph showing the albedo versus water level. And what you see is when the water level is below land surface, you have a fairly constant albedo. It's oblivious to what the actual water level is because the water's not visible into the atmosphere. But as you start to submerge the surface here at land surface zero, you just progressively lower the albedo. Same phenomenon with the tall cypress and the dwarf cypress. With the dwarf cypress, we have something of a hysteresis phenomenon here. The albedo is different on the ascending during the inundation than on the recession. Not exactly sure what is causing that, but for the most part, we are seeing a linear relationship. Notice that is the moderate resolution spectrum radiometer. There's actually two satellites carrying MODIS sensors. They're both polar orbiting, and they pass over a given point over the equator about 10:30 and 1:30 every day. So they're moving very fast. Basically 24 revolutions around the planet every day. So they can cover the entire planet in a day or two, and give you this measurement that they provide data that can be processed to infer albedo at 500-meter resolution. They have a lot more data too, by the way, but they do have an albedo plot. It's 16 days in time. They actually pass over every day, but there are clouds obscuring a given point, so they take a 16-day window, find clear days, identify albedo during that time, and present the 16-day product that's available to everyone free of charge. And that gives you the ability to measure albedo everywhere all the time, and that can be very useful because people are not usually interested in ET at a point. They want to know it everywhere because we do regional studies. So this can be a valuable product if it works. Now here's the gray curve here is the albedo as measured at one of our sites with our field sensor, and here's the albedo as predicted by MODIS. Pretty good relationship. So that's really reassuring. And MODIS also allows you to differentiate the albedo based on certain subsets of the shortwave spectrum. So here's the MODIS visible albedo, here's the near-infrared, and it appears that the near-infrared albedo is what is really driving the variability in albedo, because you see a much more variable situation with near-infrared. This is my final slide. Here are the implications. To recap, albedo impacts energy and therefore the water budget because of the late heat flux ET pairing. And we've seen that albedo is a function of water level. And so we're going to need to couple albedo and water levels in our hydrologic models. Right now, we pretty much by divine fiat to say the albedo of a given cover is such and such, and that's used to compute ET. But it seems like there's a coupling there that the two are related. You can't just mandate a certain albedo value, depending on the water level. And likewise for the global climate models that are used to look at things on a planetary level, albedo is, in terms of driving the energy budget of the planet in wetlands, needs to be a dynamic quantity of function of water levels. And I don't know if you guys are familiar, but there's work going on by the USGS. A fellow named Tom Smith is leading the effort. He's downscaling the global climate models for Florida, along with FSU. And that's going to be very useful for us because we really want to know what's the future in terms of the climate, at least in a statistical sense. And what that work has done is indicated drier and warmer conditions are coming. So warmer, we expected that, global warming. But also, generally speaking, we're going to have less rainfall. So we're going to have shorter hydro periods. And the shorter hydro periods would imply higher albedos based on the information that we just looked at. which would serve to reduce future net radiation and ET. And that would be good news in light of rising temperatures. If you have reduced net radiation and you have lower ET, that might help the situation of less rain. There are other factors, of course, but the albedo aspect of it is driving us towards lower ET values in the future with drier conditions. Anyway, that's my talk.
How y'all doing? Going after albedo, so now we're going to go to paraphyte, totally different change gears here. Specifically, we're working in the northwest section of Big Cypress National Preserve. I want to acknowledge my author, Raul Ordelis, my collaborator, and myself have been working on this project in the preserve since 2008. We're out of an office out of Miami, the Inventory Monitoring Office. So we work in a number of national parks around South Florida and Virgin Islands. So again, this work here is in the northwest section of Big Cypress. We were brought into this study because Preserve, through their work in water quality monitoring, found an increased amount of phosphorus in the water columns, and we were trying to have a mechanism that they could translate water quality impacts into the biological components of the preserve. And so this area is affected by agricultural runoff, and some water flows in on the L29 canal. And so when we started, we wanted to basically work with the preserve's already established system. These blue dots here are Bob Sopsack, Paul Murphy's water quality stations that are out in these areas. And based on the numbers that they've been generating, they show that there was an impact to the system in the water quality components. And these flowways are basically from some work with Sopsack and Klein and everywhere, suggesting how the water flows through this section of the preserve. And so based on that information, we tried to basically move into sampling the paraphyton communities. This work was based on, like I said, a prior rate assumption that all these areas in the red circles, according to water quality data, were above what the state would like to see for phosphorus, 10 parts per billion. And these areas down below are more rain-driven and not have as much of that impact from the agricultural areas above. And so we went forward with that knowledge, looking at, this is just to give you an idea, I'm not supposed to read the numbers, it's really low phosphorus and really high phosphorus in these different areas. And that's what you should take away from that, except also here there seems to be an increase over the last number of years that the phosphorus level seems to be a little bit higher. You see 56 parts per billion, which nobody likes, that's considered high. What they'd like to see is a 10 parts per billion number. So we had a little pilot study where we delineated flowways based on some hydrological suggestions. We said whether they were impacted or unimpacted, we selected sites, and we wanted to collect paraphyte samples from each of these sites. So why paraphyte? More like, what is paraphyte? So paraphyte is this blob that you found in the marsh. You have to pick it up and like, yeah, that's interesting. I don't want it on my shoes. But essentially, it's a primary producer, and it has both soft algae components, diatoms, it's a blue-green algae. And the nice thing is that there's some very, it's important, it's based two web, a lot of things keep on, all that good stuff. But also you can use it for assessing whether things are impacted or unimpacted. So mats, this is a mat, have a pretty particular characterization of being an unimpacted area. Unimpacted for this talk is going to be water quality specifically on this sort of stage. And then the assemblages, both diatoms and soft algae, have been used as indices in other places. There's a very extensive paraphyton sampling associated with Everglades restoration. They fly all over the place from the south end of the park all the way up to the lake. And they're really tying that particular metric to water flows in these different areas. So we had something to base it on that's nearby. And it's been used all over the country, but that's just our biggest next-door neighbor. And then the paraphyton community structure itself, it assimilates the hydroperiod nutrients for an entire wet season. And it's a fancy way of saying that we can go at the end of the wet season and take a sample of the paraphyton community, and there's inertia that's going on for the whole wet season. So if there's a lot of nutrients that are flowing in, or the stage is really high, that those impacts are reflected in the community. So we basically go out and take one sample and basically give you some idea of what happened over the wet season prior, and then if we do that a number of years, we can actually show you annual patterns with it. So that was an advantage of not having to sample lots and lots. Now the preserve has been doing water quality graph samples, and that's basically the competition. So whether they can get one chunk of water, it tells you what the water quality is that day, that minute. A bird comes by and poops, oh, it's all high, and there's nobody there, it can kind of go down low. So it's more of ephemeral numbers, and it's kind of harder to relate those things. So this is a way to do that. So the other advantage of the diatoms metric is the species can be accurately identified, they can be stored, you can pass them around to a bunch of paraphyletic geeks, and they can all agree that it is important. And then also the species themselves are very sensitive to environmental conditions. So a species present, because there's a big database where they collect these and everybody puts that information there, they tell you what conditions they were found in, so you can actually use those species as an indicator of the condition of the habitat. They use it for salinity, they use it for impacts of water quality. The diatom community composition, basically the fellows that are in the diatom community are very sensitive to the phosphorus instead of just looking at biomass. So sometimes people are confused that when you go out to an area like plants or animals that's impacting, say, hey, we have so much more vegetation, the nutrients must be good. And this is the clarification that that's not. We don't want lots and lots of particular growth. We want this diversity is actually an indicator we're looking at. And studies have shown that the phosphorus concentration is above 10 parts per billion, the one the state likes. There's an abrupt shift from one community type that likes low nutrients to a community type that has can deal with the eutrophic conditions. So we went out to the goals in 08 was to look at, we did both diatoms and soft algae because the diatom folks we were dealing with in South Florida said, hey, there's not a lot of work done in Big Cypress, we may need to look at the soft algae component to get this signature. So we did both those sampling. We both did impacted and unimpacted. We compared the diatom soft algae structure, be able to look at the structure itself that was collected, and then we were able to determine differences both in marsh communities and cypress domes, because when we first started this project, one of the things we were hoping to be able to do was paraphyletic collection, and at similar sites also collect fish and insect larvae to kind of tie the whole thing together. And so we were hoping to try to do all this in cypress domes, but we came smarter afterwards. So sites were 4-wheeler drive, Big Cypress, off-road vehicles on approved trails, and walk out to our sample. And here's the little orange dots now are kind of where we ran sites, and these were all kind of based on access, and can we answer this very specific question at the end. So we sent the lab samples, we're all sent off to Dan Stevenson, Michigan State, who actually counts ID, all the good stuff. We don't have to do that, that's not nice. And we did both diatoms and soft algae content. Yay, so what does it mean? So I'm going to show you a couple of these graphics. These are non-metric, multi-dimensional scaling. Sounds really nice, but it's basically a graph. And anything that's really closely related is much more related than stuff that's farther away, so that's kind of nice. The first thing we look at, we see there's a very large green circle here. We have basically our unimpacted sites all congregated together. So the composition of the stuff that's in it is all very similar. They all grouped out well, nice off by themselves. And then the three areas at the time that we were looking at that were our impacted sites, all grouped separate from the unimpacted sites. So yay, the composition works well, separates well. And then you can see not only that, but even within the impacted sites, they're definitely on different trajectories. Something's going on where they're not all in the same place. So your assumption may be that there's different amounts of impactedness in these different areas. The other part that we were interested in was looking at both cypress domes, which are these little rounds, and the triangles. It's hard to see, and it's okay because they're on top of each other. So the answer was we didn't have any big difference in the community type. So if we sampled in the cypress dome community, it wouldn't tell us something radically different than the actual marsh community for the diatoms. And what we ended up wanting to do was basically work in marsh conditions because we could identify them relatively well from aerial imagery when we pick new sites. Just to give you a photograph of what it looks like, here's an unimpacted site. There's that nice floating mat area, and then this is what you have to kind of, you can't see the floating mat. You have to dig around and find paraphyletic. The vegetation is vastly different, obviously, but this is what the impacted sites in general are looking at. They have different vegetation things as well. So we continued the study on. In 2009, we were looking at basically a spatial variability. So we selected a lot more points within a basin now. We're trying to understand what's going on in the whole basin because the preserve, remember, has like one hydrology station, one water quality station in the area, and now we're trying to expand it so we get a spatial representation of what's going on. So we got up to 65 sites doing that in 2009. And then in 2010, we went back to many of the, basically the same locations, and we did it through time because we're worried about a temporal signal. So we wanted to understand if you took a sample in 1 year, in 08, did you get the same, does it group the same place in 09 and in 10? To see, can we use this as a monitoring tool? And so we had to fly this time. And that was definitely helped by Big Cypress, Ron Clark. Thank you for paying for the flight. And the ATV trailers. What? This is off. Just wanted to safety part there. So we access the ATVs as well. So, okay, yay, more data. So same kind of graphic, same kind of idea, except everything in red here was our a priori assumption that these were impacted sites. The blue clumping is here, so the blues basically clumped together, which is kind of nice. The one obviously is like, well, that's not all blues. Okay. This area here, Kissimmee Strand, this diamond shape, was originally thought to be an impacted basin within the preserve, and essentially it groups out consistently not being impacted. The diatom community would suggest that it's not. It's basically over with the unimpacted sites. And when we went back and looked at the data a little more stringently, it is technically above 10 parts per billion, but it's about 12. So it turns out that it's not as impacted as the other basins. And there's a site further east that we may end up picking up because it tends to have a little more influence from that northern region of the preserve. Again, also I'd like to point out that in this area we're looking at spatial variability, so the idea was to hopefully that all the same symbols would be close to each other. And so for one example, Fire Prairie, which is a nice square, generally they're all on top of each other except for these two guys out here. What are you guys doing? Well, that area happens to be the north end of Fire Prairie, which is just adjacent to East Henson Marsh that happens to be impacted. So the Paraphyte is allowing us to look at basically basin variability and say, well, yeah, technically you're in that group over there, but you obviously have some hydrological connectivity or water quality moves occurring in that part of the preserve into that area. So, it doesn't lie. It tells us that, basically these things are related and they're mixing. And so that's one thing that we can go back and kind of understand for these areas. And also temporally, things that stay as unimpaired, stay unimpaired. And impaired sites stay in a different grouping. So we're finding that there's a temporal trend that's been consistent from year to year. And so we're able to use these as a way of monitoring on a grander spatial scale. And like we said, the sample is allowing us to sample over the entire season and indicate, yes, if they're impacted or unimpacted sites. So now with our new knowledge, we got smarter, so important. These basins here essentially are impacted both from the water quality long-term study, which is at one site, repetitive grab samples, and basically all our data for the 3 years now agree that these are the impacted basins. This area here basically is not very much different, which was not what we thought when we started. But areas over here, there's another flowway that basically the water quality numbers indicate in the preserve may be a place to kind of go look for impacted water quality movement in that part of the preserve itself. And so you're like, yeah, well, Paraphyte thought, what about diatoms? Well, so we have to show you a couple of diatoms. And folks that care about the diatom, there's a few the species that drove against essentially our separation. And basically the Massalia and Raxaria are the two kind of common folks that are in the unimpacted sites, and they were what the literature supported. So 60 to 70% of the composition by counts in our sites were these typical clean water associated diatoms, which is like, yay, we're like everybody else that's doing the work. And again, Galphamia and this area were the ones that were the 40 to 60% composition in our impacted sites, and that's what's also found in the literature. So our numbers make sense, what our composes our actual diatom community is in agreement with what's out in the literature itself. So in summary, we think that diatom community structure is an effective way to look at water quality impacts. You can do a spatial scale, you can afford to do this. We do confine ourselves to sampling broadly marsh communities, which has allowed us to use helicopter access instead of trying to get through trees from remote access. The Paraphyte is an effective way to spatially sample the basin, and we can actually ask questions of how much of the basin is impacted, or what would that community composition suggest on flowways through the basin itself. Because the hydrologists will tell you they understand hydrology, but then they'll admit to you, well, we don't understand all of it and kind of how it all functions. And this is a biological way to allow them to look at how these areas are connected to each other, and allow management to kind of make some decisions about where water may be coming in and where you effectively preserve. And temporally, the diatom community assemblages are both useful on a seasonal basis and annually. And we kind of suggested that during the talk, where we can take that one wet season sample. It'll give us kind of an idea of what happened over the last wet season, the nutrient cycle and the water. But then, since we've been doing it now for a couple of years, we can actually start to see if these areas have shifted. So if there is a management decision or an action where they do something, we can continue to sample areas and say, okay, you went from an impacted type of community composition, and over 3 seasons, you are working towards unimpacted, which is always nice because people like to show the progress. And sometimes there's a lot of inertia in the system because of cycling nutrients and things like that. So it may not be an instantaneous response, but we're able to show, hey, this composition is slowly changing through time. So we like to focus, like I said, this area is presently east of the Kissimmee Billy Strand, and we like to pull that information in. Here are the two marshes. Currently, we're working in what's technically the marsh called Little Marsh, where they take a sample, and you can see that number's kind of lower. And then the Kissimmee Billy Strand, proper water quality sampling station, which again is to the east and has some logistical issues getting to, has a higher signature. So I think we're going to try to move and incorporate that sampling here in this next year's sampling. And I'd like to thank the Big Cypress staff, specifically Ron and Bob Sotzak, our hydrology folks. Bill, Ryan, this place is always nice and walking. Jim and John Town also helped us get out there and get the work done.